This video is about modeling and applications with linear equations. So one thing that we know is that when we have word problems, application problems, students kind of avoid them, which is not the best course of action. You don't get better by avoiding, but you do get better if you practice setting things like this up. So we want to talk about some of the verbal expressions that can translate to algebraic expressions. So for example, one number exceeds another by a. So we could have the number is x, and then it's exceeded by a, we would add a. Twice a number would be 2 times that number. One number is a more than another number, then we would have x and x plus a. Less than twice another number, a less than twice another number, and so on. So there are a couple words too that translate into different words. Sum is addition. Very often the word total will tell you you're trying to add things up. Difference would be subtraction. Product would be multiplication. And quotient would be division. So anytime you're going to solve or set up an application problem, you want to make sure that you read through the problem first in its entirety, and then always identify your known quantities and assign variables to represent the unknown quantity. I'll give you some hints on that as we work through these examples. So for example, Aaron's going to see a movie and is taking 2 kids. Each movie ticket costs $15, and there are an assortment of snacks available to purchase for $3.50 each. How much total money would Aaron have to pay for his family if he were to buy 2 snacks for everybody to share? How much would Aaron have to pay if he bought X snacks for everybody to share? So here we're not solving anything. We're just going to write down some information. What do we know? Snacks are $3.50 each, and admission is $15 each. So his total admission cost, since there are 3 people, 3 times 15 is $45. His total snacks is going to be however many snacks he has times $3.50. So here we're going to let X be the number of snacks. So here's that word total. How much total? So we're going to add these things up. And the first question is, how much would he have to pay if there were 2 snacks for everybody to share? So in that case, the total would be the admission cost plus the snack cost, which would be $45 plus 2 snacks at $3.50, which is another $7, so $52. If we're going to answer the second question, if he bought X snacks, then we're going to say his total admission is $45, and X snacks times $3.50. So we would probably write this as 3.5x plus 45. And this would allow us to find the total value if he bought X snacks, and we could plug different values of X in, or if we knew how many snacks we were going to buy. Oh, that would be if we knew how many snacks we were going to buy. But what if I had $100 to spend? That would tell me how many snacks I could purchase. So here's another example. A group of friends wants to go to an amusement park. They have $99.75 to spend on parking and admission. Parking is $17.25, and tickets are $13.75 per person, including tax. Write and solve an equation which can be used to determine P, the number of people who can go to the amusement park. So we're going to start this by saying, because they ask us that, let P be the number of people that can go. And parking is $17.25. And ticket cost is $13.75 per person, so times the number of people is P. So again, we've basically got the total is the parking plus the tickets. And notice how I write this as just kind of a model. So our total is going to be $17.25 plus $13.75 times P. And we're told that they have $99.75. So we'll plug that in here for T. And find out how many people they can take. So we're going to first subtract from $99.75 the $17.25 and get 82.5 is 13.75 P. And if we divide by 13.75, we get P is 6. So hopefully their vehicle can handle 6 people. Usually most of them can. So we're going to answer the question in a sentence. 6 people can go to the amusement park. We want to make sure that we're answering our question in a sentence as opposed to just saying P equals 6. Okay, last example on this one. This is more of a geometric example. Use a formula to solve a real-world application problem. The perimeter of a rectangular outdoor patio is 104 feet. The length is 3 feet greater than the width. What are the dimensions of the patio? So I have a couple of things here. I know I have a rectangle, so it's a good idea to draw a picture. It's a good way to identify your variables. We know that the perimeter of this is 104 feet. And you should also know a formula for perimeter, which is 2 lengths plus 2 widths. So I'm going to call this L, and I'm going to call this W, and this L, and this W. Now it's telling me that the length is 3 more than the width? Is the width plus 3? So rather than writing this equation with an L in there, I'm going to write it as 2, and then our L is W plus 3 plus 2W. And let's go ahead and simplify. 2W plus 6 plus 2W, or 4W plus 6. So that's our perimeter. And we know that our perimeter is 104. So 4W plus 6, and we'll solve. 104 minus 6 gives us 98 equals 4W. And our W is 24.5. Now, the question, and this is why we answer in a sentence, is what are the dimensions of the patio, not W. And this doesn't have any units. So we're going to say the dimensions are a width, that's what we solved for, W, of 24.5 feet by length, and length is that W value that we found plus 3, so 27.5 feet. If I had just left it as 24.5, I would be missing two things. One, the length, and two, any kind of units that we needed to have. So make sure that you're answering your application problems using a sentence and including all of your units. That concludes this video. Thank you. Have a great weekend.